All right, we are doing lesson 18, exercise 18, and we're going to be looking at numbers 1 and 6. This is our conditional proof assumption lesson, so that's what we're going to be doing. All right, number 1, we have if A, then B and C, therefore if A, then B. Right out of the gate, we're going to assume this antecedent here. So that's going to go on my second line. I'm just going to write A. And right next to it, I'm going to write CPA because this is our conditional proof assumption. So I have just assumed A, and I can look up here and see what else can happen because of that. And I have this conditional here, and the antecedent has been assumed. So using modus ponens, if you remember our rule over here, if the antecedent in modus ponens is affirmed, then the consequent is concluded. So I can conclude then B and C because of that modus ponens. So I'm going to write B and C. Just so you can get more familiar with this, I'm going to write it over here. If P, then Q. P, therefore Q. And what it looks like for us in this problem would be if A, then B and C, A, therefore B and C. Okay, so, and remember, anytime like you're doing a rule, the conclusion will be what's on the line over here. So my first premise was line 1, so I'm going to write 1. My second premise was A, which is line 2, so I'm going to write 2. And I used modus ponens. All right, so now remember what we're trying to do is to deduce this consequent of B right here. So that is what we're going for. And if you look at 3, we have B and C. So we have to think, is there a way that we can get B by itself using one of our rules? And if you remember simplification here, it is using a conjunction and taking it down to a single variable within that conjunction, which is P. Also remember with this rule of simplification, you cannot take the Q. You would have to take the one in the position of the P. But we also learned that there's a rule of commutation where if you need to, you can just switch positions there if you ever need to get that other side there. But we don't have to do that for this one because B is already in the right position. Whoa. All right, so I'm going to write B here. And what I did is, oh my word. Okay, I used line 3, simplification, and I got B. So if you notice, I got what I was looking for. I deduced that consequent, so I'm actually done. So when you're done, when you deduce what you're going for, you end it and you just rewrite the whole thing. So I'm going to write if A, then B, because that's what I was going for over here. And what I also write is the whole entire list of lines that I used, which was 2 through 4, C, P. That's what I write when I'm done. Okay? All right, so that's the first one. Now let's move over here and look at number 6. We have if Q, then R and S. If R or S, then T. Therefore, if Q, then T. We are assuming the antecedent in our conditional again. So we're looking at the conclusion in this one. So we're going to assume this Q. Look how my pencil is so little bitty. Look how little. Okay, it's making it kind of hard to write. Okay. We assume Q. And I'm going to write C, P, A right there. Now, looking up above, we can look at what can happen because of that Q. We have a Q in the antecedent here. And using modus ponens again, modus ponens is used a lot. This consequent will also be concluded. So I'm going to write R and S. I'm going to rewrite that modus ponens over here. If P, then Q. P, therefore Q. What it looks like for us in this one is if Q, then R, and S. Q, therefore, R and S. Here's the conclusion, and it shows up in our line here. The lines that I used was, my first premise was line 1. My second one was line 3. And I used modus ponens there. Now let's look at what we have and what we're going for. We're going for T. T is in this line 2, and it is the consequent here. And what we have in the antecedent is a disjunction. We don't have this disjunction by itself. We have not affirmed it yet. How do we get it? What we have is R and S, but we don't have anything. Working with what we have, we cannot take a conjunction and turn it into this disjunction that we need. There is a rule with De Morgan's theorem that can turn a conjunction into a disjunction, but it doesn't fit with what we have, which is this R and S, simply by itself. But I can actually simplify, get the R by itself, and then use addition to add the S to make it look like this disjunction here. So let's look, and I'll show you what I'm talking about. So here's our simplification. This is what I have. I have a conjunction, and I can use simplification to get the variable. Then I can use addition to take that variable and add something else using a disjunction there. So that's what I'm going to do. I'm going to take that R and S, simplify it. So I used line 4 and simplified it. Then I'm going to take this R and use addition to make it R or S, because that's what I need in my antecedent up here. So I used line 5, addition. Now, because I have just affirmed the antecedent and the conditional that I need, I can now conclude this consequent, which is what I was going for, was that T. Now I'm going to write that over here so you can see. If R or S, then T. R or S, therefore T. So I have just done all this work to deduce that T, get it by itself. So I am done. So then what I do is I go back and write the whole thing of this conclusion, or what I was assuming here. If Q, then T. And then I use the whole lines that I used, which was lines 3 through 7. CP. All right, and because I assumed the antecedent of Q, and then I deduced the consequent of T, I am done in CPA. And because that if Q then T is our conclusion, I'm done. If I were to keep going, I would not be able to use anything within that assumption work that I did there. So that is conditional proof assumption lesson and exercise 18, and I hope that helped.